Imagine floating in the infinity of space where our sun is just visible. In this remote corner of the world lies the planet that was once known as the ninth planet in the solar system, now reformed and shrouded in mystery. This is Pluto, a celestial body that continues to amaze scientists and astronomers. Our journey begins with the New Horizons spacecraft, an incredible probe of human intelligence sent to discover the secrets of this mysterious dwarf planet. Join us as we explore the known planets to uncover the amazing sights and mysteries of Pluto. At 1,475 miles in diameter, Pluto may not be one of the most impressive objects in the celestial sphere, yet this famous dwarf planet is not without spectacular sights that will amaze experts and the public alike. To take a closer look at the oldest member of our planetary system, NASA sent the New Horizons probe to Pluto a few years ago. The unmanned spacecraft didn't reach the Kuiper Belt object until 2015, but the mission produced high-resolution images of the tiny celestial object. Today, we want to show you the fascinating details of Pluto. Will you join us on our journey into the world's greatest mysteries? Remember to subscribe to our channel and click the bell so you don't miss our future videos. Just let us know that you like our content and give it a thumbs up. It's August 24, 2006, and Pluto has been stripped of its status as a planet. More than 70 years after it was first discovered, Pluto has become a powerful member of our planetary system. However, this changed when the original concept of the planet was redefined. Before this scientific discovery, many other objects had been found in the Kuiper Belt, some as large as Pluto. To prevent the number of known planets in the universe from jumping to unmanageable numbers, a new dwarf planet class was introduced. Now classified as a dwarf planet, Pluto orbits the Sun at an average distance of about 4 billion miles. Due to its unusual orbit, this dwarf planet takes 248 years to completely circle our host star. The great distance between the Sun and Pluto creates freezing temperatures that dominate the celestial body. In fact, Pluto's thermometer does not rise above -360 degrees Fahrenheit. At about 6.8 million square kilometers, Pluto's surface is about the size of the continent of South America. This dwarf world is 70% rock and 30% water ice. We currently know that Pluto has at least 5 natural satellites, with the largest and most famous being the moon Charon, discovered in 1978. This satellite is about 750 miles in diameter, making Charon more than half the size of Pluto itself. Due to this amazing size ratio, it is called the Pluto-Charon binary system. Unlike the Earth-Moon system, the center of gravity around which the two celestial bodies revolve is not within Pluto but outside it. Thanks to the many images taken by New Horizons during its visit to Pluto, we can see the celestial surface in more detail than ever before. The image showing Pluto in all its glory was taken by the spacecraft from 2,200 miles away. This image is corrected so that we see it in the natural colors that the human eye would perceive when looking directly at the celestial body. What strikes us when we see this amazing image is that Pluto's exterior is decorated by small features that suggest the surface has been renewed over thousands of years. It seems that Pluto may not have escaped galactic collisions, and as a result, natural processes must continue to work on the small celestial body, covering all the collision marks over time. On our home planet, meteorites create similar phenomena, with wind, water circulation, and vegetation erasing the impact craters. Pluto's surface can also be seen to be divided into very bright and very dark regions. In fact, the dwarf planet exhibits the second highest brightness contrast known in the universe, surpassed only by Saturn's moon Iapetus. Pluto's large icy region, named Sputnik Planitia, is named after the satellite that was the first human-made object to leave Earth. Because this plane has no impact marks, some experts believe it was formed less than 100 million years ago, and the process of land change may continue to this day. At first glance, the ice surface looks like a frozen dirt floor, with visible depressions in the ground that may result from wind influence. The images from Sputnik Planitia showing ice on Pluto's surface are fascinating. The flat surface of Sputnik Planitia runs into an impressive chain of mountains, whose size is nothing to be ashamed of compared to Earth's mountains. Among the impressive elevations on Pluto are the nearly 11,500-foot Mount Norgay and Mount Hillary, which run along the western edge of Sputnik Planitia and tower nearly 5,000 feet above their surroundings. Most of the time, these formations are not just rocks but liquid ice hardened into rock due to extreme cold, a common occurrence on dwarf planets. How these icy peaks formed on a celestial body without the influence of a larger celestial body remains a mystery to scientists. This high-resolution image of Pluto's surface structures shows what the dwarf planet's surface looks like at its core. In this color-enhanced mosaic, we see a nearly 50-mile wide landmass stretching from the edge of the so-called Badlands to the icy regions of Pluto. To the right of this amazing image, we see the dark heights known as the Cthulhu Macula. What immediately catches our eye is the dark red color of the area, which experts believe is created by tholins, a combination of organic molecules such as hydrogen, carbon, and nitrogen. This compound is said to be abundant on Pluto, giving the dwarf planet its reddish-brown appearance. The Cthulhu Macula rises 1.5 miles above the surrounding terrain, with connecting holes clearly visible. The structures are 5 to 8 miles wide and 1.5 miles deep. Due to Pluto's very thin atmosphere, mostly composed of nitrogen with traces of carbon monoxide and methane, its protective shell is delicate. Thanks to data collected by New Horizons during its mission, we know that Pluto's atmosphere extends 1,000 miles above its surface. The carbon monoxide, with an internal temperature of -364 degrees Fahrenheit, creates a cold environment, while the lowest surface temperatures are much warmer at -292 degrees Fahrenheit. This difference is likely due to the evaporation of methane from a solid state into the atmosphere. Looking at Pluto's north pole, we observe the geological diversity governing this small celestial body. The Arctic region is marked by long trenches, with the largest being 47 miles wide. The valleys near this rift structure are about 6 miles wide. These canyons appear to be older than others found elsewhere on Pluto. The existence of polar ice caps indicates significant factors in the early history of the celestial world. An unmapped view of the canyon system reveals an area known as the Tombo Regio. Scientists still do not know the origin of these many indentations on the surface, but many believe they were created by glacial infiltration and natural evaporation. Since the area shows few collision signs, it is reasonable to conclude that it was formed relatively recently. Individual craters reportedly extend several feet into the ground, with hundreds of feet in width. The arrangement of these structures allows scientists to draw important conclusions about the exchange of nitrogen between Pluto's surface and its atmosphere. Dive deep into Pluto's mysteries. New Horizons' mission to Pluto is more than just a space tour, it's a journey back in time, revealing how this dwarf world evolved over billions of years. The spacecraft's detailed images have opened a window into Pluto's past, uncovering clues about the processes that shaped its surface. As we delve deeper into Pluto's mysteries, each aspect tells a story, each chapter revealing a part of Earth's history. One of the most striking features of Pluto's surface is its youthful appearance, with the absence of craters indicating a constantly renewing surface. It's likely that cold volcanoes, liquid ice, or other non-volatile matter flowed to the surface, creating the flat plains and modern appearance of Sputnik Planitia. Pluto's mysterious mountains, made of solid water ice, are as hard as rock due to extreme cold, and the forces that created them remain a mystery. Unlike Earth, Pluto lacks tectonic activity driven by a molten core. Theories suggest that nitrogen dioxide may have pushed down these ice sheets, but this is still debated. Pluto's thin atmosphere, with its layers of fog seen by New Horizons, indicates complex interactions between the surface and atmosphere. As Pluto moves closer to the Sun, surface ice heats up slightly, creating a temporary atmosphere that dries out as the dwarf planet moves away. The legacy of New Horizons flyby has revolutionized our understanding of this distant planet. Before this mission, Pluto was just a speck on the edge of the solar system. Now, we have detailed maps showing a complex and diverse landscape that rivals the inner planets. The data collected by New Horizons will be analyzed for years, providing insights into Pluto's geology, atmosphere, and potential for future discoveries. This mission also raises new questions. What energy source drives terrestrial activity on Pluto? How do surface and atmospheric interactions function and evolve? What can Pluto teach us about other icy bodies in our solar system's outer reaches? The future of Pluto exploration remains bright, with future missions likely to continue unraveling the mysteries of this fascinating dwarf planet.